When students begin algebra studies, one of the most difficult concepts for them to master is operations involving positive and negative numbers. In order for them to fully understand how to perform addition and subtraction with positives and negatives, we have to use a particular example of a related idea that they understand fully, and then transition that into this so-called new concept of signed numbers. One of the first things students need to be taught is that positive and negative numbers really have no difference between them other than the fact that they are located either to the left or to the right of zero. If we're looking at negative numbers, for example, these are all of the units that have been placed to the left of zero on the number line, while the positive numbers are always found to the right. And there always will be this relationship that exists between them that is determined by looking at opposite directions. So let's introduce the term absolute value here for just a minute. Absolute value is described as the distance a number is from zero on the number line. And if we think about absolute value, then we don't really think about positive and negative. We only think about how far from zero. In the way that positive and negatives are going to be explained in textbooks, they say interacting positives and negatives has to be based on their absolute value. Now, my take on this is that we might talk about something that kids understand, that students will relate to, and that's a thing called a tug of war. In a tug of war, you always have two teams, and in order to explain the mathematical concept of combining or adding together positives and negatives, I'm going to refer to our two teams as the positive team and the negative team. The positive team is going to line up on the right-hand side. The negative team is going to line up on the left-hand side. And if we assume that all of the members of each team are approximately the same size and the same strength, then we should be able to determine from this graphic that the negative team having only 5 individuals pulling versus the positive team that has 7 members pulling to the right side, that the positive team is going to win. And being able to make that assertion in mathematics is very, very important for students, because most of the time when they miss a problem involving signed numbers, it's because of the sign of the final answer. Well, you can see here that it's very easy to determine who's going to win. The winner is always going to be the one that has more people pulling in their given direction. So obviously the positive team is going to win here. Now the second part of the problem would be, well, why exactly does the positive team win? I mean, be very, very specific. If the positive team has 7 persons pulling and the negative team only has 5, why is it that the positive team wins? And the answer is because the positive team had 7 players, the negative team had only 5. 7 is 2 greater than 5. Notice I'm talking in terms of absolute value here. I'm not comparing 7 to negative 5. I'm saying the absolute value of the positive team is 7. The absolute value of the negative team is 5. And since 7 is greater than 5 by 2, once again, how do we determine that? Well, 7 minus 5 is 2. Then now we've avoided all the pitfalls of that algorithm in math that describes how do I add positive and negative numbers. We're taking something that's in a written form that can be very misleading to young people, and now we're saying just look at it this way. This is something you understand. This is something you can relate to. Therefore, your solution that 7 plus negative 5, oh, by the way, it doesn't even make any difference which way we arrange those, negative 5 plus 7, it's still a competition between negative and positive winning because they have 2 more players, and we avoid all the problems that go along with the learning of math. Now, just so you can better understand the type of frustration that students go through trying to learn math in a classroom, let's look at the alternative to what you've just seen. Let's look at a typical classroom and a typical math textbook trying to describe how to combine signed numbers. First of all, it would say that if you are adding signed numbers, then it's important to recognize that if the signs are the same, then the sum will contain the same sign as the original numbers. If both signs were positive and you add two numbers together, the answer is positive. I guess that goes without saying. If both are negative, then the sum of the two negatives is a negative number. Now, I'm not saying that in its own right is difficult. However, when students get into multiplication later, they discover that when the signs are the same in multiplication, that the answer is always positive no matter what. So we're setting students up for failure. But here's the second part of the algorithm, and it says when combining signed numbers of unlike signs, then take the absolute value of both numbers, subtract the larger absolute value minus the smaller absolute value, and assume the sign of the number that had the larger absolute value. Okay, now wait a minute. See, to me that sounds incredibly difficult for students, especially when they are first learning how to combine positive and negative numbers. But if we tell them adding positive and negative numbers is a tug of war, they will always know who wins, and they will always know that they won because they had more players and how many. That's Math My Way. That's what I believe is best for students who are first beginning to comprehend the ideas of math.